Hey again, guys. All right, so this video is going to do part of section 2.3. I'm going to break it into a couple different videos. So this one is really just talking about measures of central tendency, which you may have never have heard described that way, but I'm sure you've heard of the mean, median, and mode. So we call this the measures of central tendency because we're really trying to figure out what is the best center of the data. So that's why we call it central tendency. Now, which one out of these three, they all describe the data a little bit differently. One kind of describes the position, one is the average, and one is the one that occurs the most. So throughout this, even though I know you know how to do those already, we're going to talk about which one for data sets is the best representation. So you'll want to probably stop the video and just copy down the example that I have so that you've got the data in front of you so that as I'm doing the slide, doing the video, you can take notes along with me. So I've got a set of test scores for a class of 15 students, and they're listed below. And what we're going to do is we're going to find the mean, median, and mode for this data set, and then we're going to talk about what's going on and which of these three things is affected most by certain data values and things like that. So let's start with the mean. Okay, I'm sure you know the mean is just the average of the data set. Okay, so what I want to focus on, since I know you already know that, is some notation. So this is there's two symbols we use for mean. Okay, the first one looks like this. People think it's an M, but it's not. It's kind of a U. Okay, we say it as mu. It's a Greek letter mu. Okay, so mu is a symbol for the population mean. Okay, so if I know it's from a population, meaning I have, let's say this class only had 15 students and I got the test scores for all of them, then I would use mu because it would be a population. Okay, or otherwise I'm going to use, and I'm going to write something over here in a second, we use what's called this X bar. That's how I say this. Okay, so X bar is just the same thing, but it just means it came from a sample. It's just a different symbol. Doesn't really matter for a average, for a mean, which one I use. I can use them interchangeably, but you'll notice when we go ahead into section 2.4, we will really have to distinguish if it's a population or a sample. Okay, so how do I find an average? I want to put this into our symbols. Some of them we already know. So I find the average by summing up and dividing by however many values I have. So let's use our sum notation. So this means we're going to sum up all of our x values. Our x values are just meaning our data values. And we're going to divide by n. Okay? That's really that's the formula we use for an average in statistics. Okay, the same thing for sample mean. We're still going to sum up all the x values, all the data values. Notice I'm going to use a lowercase n. And that is just for when it's a sample. And that's just for a population. But we have already talked about what n is, and it's the number of data values. Okay, so if you do that, if you sum these up and you divide by this one's 15, we're going to find that for this data set, mu is, it comes out to be about 74.3. Okay, so let me just talk really quick about our rounding rule here. Okay, when we're calculating something, so I am calculating a mean for these test scores that are whole values. So if I'm doing a calculation, the rule of thumb is to leave one more decimal place than the data it has. Meaning the data values here are whole. So if I leave one more decimal place, that means I'm going to round anything I calculate to the nearest tenth. I'm going to give an extra kind of decimal place, just to keep it more accurate. Okay, so that's really our rule of thumb for our rounding rule. Okay, so our mu is 74.3. Okay, I want you to kind of keep a look at these values, and I want you to notice, we're going to talk about it in a minute, but I have this value right here that's quite a bit lower than the other values. We're going to call that something in a minute. But when I did my average, that 35 probably brought down my class average quite a bit because it was quite a bit far removed from the rest of the score. So we'll talk about that again in a second. Okay, so let's median. Okay, so the median, so the average is the mean is the average. Okay, so that gives us one representation, one way to represent the data. But the median is a different way to represent it. So the median is the middle data value, or the middle of the data set, I should say, because it's not always a value, because depending on if we have an even or odd number of data values, it's not always an actual data value. Okay, so the middle of the data set. Okay, so this is also called the 50th percentile. Okay, so that's really the middle. Okay, so if set has an even number of values, the median is the average of the middle two values. So the easiest way to do this, it's not fun for large data sets, but is you're going to list all the data in order. Oops. You're going to list all your data in order and then find your middle data value. So if you do this, I didn't have that data set in order, but if you go and list those 15 values in order, you're going to find for this one, the median is 77, because this one had an odd number, so it was your 8th value. That would be the middle. That would have 7 on each side, so that represents the middle of the set. So the median of this one is 77. Okay, so in a second we've got to talk about this median versus the mean, because they came out different in this one. But let's quickly just do the mode. That's an easy one to do. So the mode is the value that occurs the most frequent times. Occurs with the greatest frequency. Okay, it would have no mode if everything occurs only once. Or all the same, I should say. Let's say everything occurred twice or everything occurred 3 times. That would have no mode. And it could be bimodal. Let me just move this up a little bit. Okay, bimodal would be if 2 values both had the highest frequency. Okay, so in this case, our mode, the only one that occurred twice was that 77. Okay, so that would be our mode. So the median and the mode in this one became out the same. That doesn't always happen. It does in certain kinds of distributions, and we'll get to that in a minute. But the main thing I want to point out is that the median came out quite a bit lower than the median in this case. Okay, and that's because of that 35. So that 35 was so far removed, it affected that average. But if you think about it, the 35 did not affect the median, because let's say the 35 had been a 55. Okay, it still would be the lowest value, so it wouldn't affect the median at all. It would still be that lowest value when you put them in order. My median would still be 77. But if that 35 were a 55 instead, my mean would have been much higher, probably much closer to 77. Okay, so when I have outliers, okay, that 35 is what we're going to call an outlier, then the mean gets pulled one way or another, whereas the median doesn't get skewed. Okay, which describes the data the best. Okay, so let's go through what we just said. So I'm just going to put a little asterisk here. If the data has an outlier, let me just put what that is. Which is a value that is far removed from the rest of the data. Okay, so really that's kind of vague, right? Because how far is far? You know, is 35 an outlier? Is 55 an outlier? That, when we get further into standard deviation, things like that, we'll have rules. We'll know, we'll have a little test to say, is this an outlier or not? For right now, we can tell that 35 is far removed. So 35, all right, let me just finish this kind of thought, sorry. If the data has an outlier, which is a value that's far removed from the rest of the data, then the median is the best representation for the data. Okay, if there's no outliers, usually the mean and the median come out about the same. Okay, in this last step, because of that 35, the 35 pulled my class average down to 74, whereas the median and the mode, both of those were 77. So 77 is probably, if I had to say how did the class do, 77 is probably a better representation because this one did have an outlier. Okay, so let's look at, so I'm going to flip this. What you're going to want to do is I would stop the video right now and just take it, just sketch these out in your notes. You definitely want a picture of each one of these. It doesn't have to be perfect, but you notice I have 4 kind of types here, okay? So take a minute, draw those out, and then I'm going to underneath describe each one, okay? So the first one on the top left, okay, that's ideal. Like that's how we want, you know, if a teacher gives a test, that's how I want my scores to look, right? I want about equal number low ones as high ones, and most of them in the middle, okay? So this is what we would call a symmetric bell-shaped distribution. This means if I had done a frequency table and these would be the histograms, okay? Think about the histograms that we did in class the other day. And that's what we're kind of describing. If I made a frequency table for my scores and I would try to fit them into one of these scenarios. So in this case, when I have a nice symmetric bell shape, my mean, my median, and my mode are all good representations. They're all right in the middle. Okay, so any one of those would be a good representation. That wasn't the case with the one that we just had here. Okay, so the next one over, it doesn't. It's more like most of them, they come out about the same. Now they're not perfect. Rarely are you going to have it to be perfect, but this is what we would call uniform distribution. And if I did that, my mean, median, mode would all be, it is still somewhat symmetric. So it's kind of a fancy case of the one before. It's not bell-shaped though. But you could still say it's fairly symmetric. Okay, and then a lot of times these two things happen over here. Okay, let me put the names underneath and then I will kind of describe what happens here. So this one right here, this one on the bottom left. So this is what we call, has a left tail. So if you look at this area right here on the left, okay, the left tail is the skinnier tail, okay? And I think we had one like that the other day. So the left tail, it means that this is skewed left. You can call it skewed left, or you can also call it negatively skewed. Okay, that's what, if I had drawn that one from the test scores that we just had, this is how it would look like, although we would have one value kind of off on the left. So the thing is here is that, well, here's my mode, right? That's the highest frequency one. My median is probably somewhere right here. And here's the thing, my mean is right here. So because I have some low values in here, my mean gets pulled down further than it gets pulled to the left. That's why this is called left-tailed. We intuitively want to call this skewed right, but it's because my mean is skewed left. Okay, it's pulled down from some lower values. So quite the opposite, this over here, this has a right skinny tail, okay? It veers off to the right. So this is what we call right-tailed or skewed. Right-tailed or right-skewed, and positively skewed. Okay, and that's so same thing. It's that now the median and the mode, they could be the same, they might not be. But you notice the way I happen to draw this one, I would have my mode here. I'm sorry, let me fix that a little bit. Okay, so my mode would be right here. My median is probably right about here. But more importantly, the idea is that my mean is to the right. The mean is to the right of the median, okay, meaning I had some higher scores that pulled my mean to the right. Okay, so maybe the mean is not the best representation there. It doesn't always mean there's an outlier, okay, because these I don't have one particular value that's way off. But in this case, the median would be the better representation, okay, because the mean got pulled to the right. So those are our 4 types of distributions. They come up over and over. So this is a great picture to have in your notes, nice and labeled the way we have it here. Okay, so you'll see another video with a couple more examples from section 2.3.